Hello, fellow cadets and Kerbonauts. This is Kerbal Training Academy. I am Blackendrose, and I will be here to teach you how to get up into space, how to successfully get into orbit, how to successfully build rockets, and maybe, just maybe, even get to landing on the moon. Yes, this is a new series that has been inspired by a couple of people that I know who have been playing Kerbal Space Program and indicated that they've had some struggles with the game. Now, there's been a whole heap of tutorials out there, and I'm probably going to make mistakes in my own tutorials, but let's just get into it. Now, in order to get started with this, what we are going to do... have I got any resume? No, I don't. Now, this is vanilla Kerbal Space Program. There are thousands upon thousands of mods for this, but for the purposes of this training, we're going to do the vanilla game with the vanilla parts, and to start with, we'll do it in the sandbox so I can show you some of the concepts, and then if this series keeps going, I'll then jump into the career mode and give you some pointers on how to get started. Now, so, Kerbal Training Academy. Now, I've left it on normal because of various reasons. Yeah. Now then, I'm not going to go through... This isn't like a tutorial on the entirety of the game, so all of this stuff you can work out. I mean, we've got the astronaut complex, the space plane hangar, mission control, administration building, research development. In the sandbox mode, this isn't used. So we don't have to worry about that. The tracking station, the launch pad, blah, 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 blah. Anyways, let's get right into it. Now, I'm going to try and use basic components, because in the career mode, that's where you start off with. You don't have access to all the exotic and massive stuff to start with. So what I'm going to do is get started on a few of the basic concepts. Now, obviously, we need to start with a command pod. So let's start with the earliest one that you can get. Now, a handy trick in building a rocket is, thank you soundtrack, is to get started with what the purpose of the rocket is. So, let's say, for example, this one, its whole purpose is just to get into orbit. So, we need to consider a few things. Firstly, we need to build the actual orbiter itself. The process I normally go through, now this isn't the most efficient process I know, but this is the process I go through, is I'll just attach, let's start with just attach like a small fuel tank and the Terrier liquid fuel engine. Now, this is important. This setup is only, this part here is only being used for orbit, because the Terrier, and put it up here, it has, let me right click on that, its thrust is pretty poor, but its engine ISP is actually relatively good. This means that in a vacuum, which is in space, it's actually really fuel efficient. But because it doesn't have much thrust, it can't push heavy loads very well. And this is what's called, or what I refer to as, the thrust to mass ratio. And I don't think that's actually a thing, but that's how I refer to it. Basically, if you need to push something that has a lot of mass, you need a lot more thrust to push it. But because this part here is very small, this small engine can push it. So we've got no problems there. So, we now have the part that's going into orbit. But we also need to consider the fact that if we're going to put Kerbals in this, we need it to get back from orbit. So, I think it's under utilities, we need to put a parachute on this thing. And what I tend to do is I put a few parachutes on for good measure. Now, let me just see, yeah, thermal. Now, because this is on normal, you're affected by heat. And obviously when you're coming in for re-entry, you have friction generated heat. If you're coming in too hard and too fast, like too steep, your parts will actually overheat and explode. Now, to get around that, I'm just going to make some modifications. What I tend to do, now, like I say, there are other methods to do this, but I will load a simple coupler. No, actually, no, not yet. Now, which one is it? It's that one, I believe. Now, that's a heat shield, and what that will do is it has ablator in it. And what this does is it breaks down slowly through heat, but it stops the rest of the parts overheating as long as the heat shield is the focal point for the heat. And we'll see that in action. And I'm going to put a decoupler on there so that when I'm coming back into orbit, I can detach the bottom part so that the heat shield is the part that's being exposed to the heat on re-entry. I also need to make some modifications down here. That's wrong. Move that around. I'll go through the order of things later. So, we have the basic orbiter. Let me just put some electrical components on there so that we don't run out of electricity. Now, I mean, this is just very rudimentary stuff that I'm just sort of knocking on here at the moment. Actually, we won't put that on. We'll put that early one on. Now, as you can see, I'm putting a lot of parts on the orbiter itself. You have to be very careful with that, and I'll explain that in a little bit. But first things, we're not going to put any science experiments on here for now, because the whole purpose of this is just to get up into space and get up into orbit. Now, we need to put another decoupler down here. So, now we've built the orbiter. Move that up a little bit. Now we need to make the actual rocket that is going to get us up into orbit. And what I tend to do, and like I say, it's not for everybody, but this is what I tend to do, is I tend to use a simple, or relatively simple. Now, let's see, what's the difference? Right, so this one has more thrust. I'm deliberately not using the larger components at the moment because you don't have access to those to start with. I've also not put any RCS thrusters on there. They'll be used for a much later session. Now, I'm going to say now, there are chances that these rockets won't work. I'm not perfect at this in any way, shape or form. Right, so we now have the liquid engine rocket that is going to get us from mid-atmosphere up into orbit. Or at least it's going to be used for the various manoeuvres. This is just the way I do it. Now, what we're going to do is we're going to put some radial decouplers. I usually go for 4 on this for stability purposes. And what we're going to do then is we're going to use this, the thumper. Now, on the larger rockets, I tend to use the kickback. But we're going to use the thumper for this one because of the size of the rocket. Now, solid fuel engines work differently from liquid fueled engines. Once you engage them, they don't stop, and they keep going at full thrust. You also can't manoeuvre them quite as well. There's fixed engines and there's gimbaled engines. Fixed engines, well, let me put it this way. Fixed engines, the part at the bottom here doesn't move, so it can't adjust where it's pushing the propellant out. So it will just go straight in a straight direction. With that in mind, that means that these solid fuel engines are very good at going up, not very good at changing direction. So we need a means to change direction. Now, since we'll still be in the atmosphere when we're using these, we're still affected by the atmosphere and wind resistance. So what we want to do is get some aerodynamic parts on there. Now, what I tend to do is throw these on the top, because that helps with cutting through the air to try and have it coming to a more direct point. But we'll go over that in more detail in later parts. What we are going to need is some wings. well, no, these aren't just wings, these are control surfaces. Now, what I tend to do is I switch on to the snap mode so that it snaps a bit better. And I tend to put a selection of 4 on the top and 4 on the bottom. Now, the reason for that is because every time I've tried to build these rockets before, whenever I only put them at the top or just at the bottom, the rocket starts to become unstable. And I'll go over some more science behind that once we get this thing going. What I also tend to do is, for structural stability, is to use struts. And what I tend to do is put struts between them like this, and also attach struts to the rocket itself. And I'll put that. No, that didn't work. Right, let's try that. There we go. Now, the reason for that is the only thing that is attaching this to the rocket at the moment, well, before that, was these decouplers. And what happens is, because it's only such a small surface that's attaching them, when the rocket tries to lift off, the solid fuel engines are trying to get away from the rocket. And what happens is, this can cause the rocket, the solid fuel engines to sort of dip inwards a bit. So that means not all the thrust is coming down, some of it is coming out. And that puts more pressure on the rocket, and sometimes can cause it to spin and be a bit more unstable. So what we've done, by putting these struts between the rocket parts, they don't move from their central point. I've also put these ones from the solid fuel engine to the liquid part itself to try and give it more stability, so that it doesn't shake about so much. The whole thing is now one complete structure. And now we have a very basic rocket. Now, there's a chance this won't get into orbit. I'm going to say that now, because some of my methods, when I'm actually flying these things, don't necessarily conform to what people say is the best method. But anyway, we now have a basic rocket. We have parachutes on them for getting back. We have a heat shield for getting back. We have communications, which is useful for the science part of it. We have energy generation, which is very important. If you run out of energy, especially on unmanned craft, you have no more control over it. So it's very important to make sure you have enough energy to keep going. We have the upper part with a small liquid engine and a small engine for orbital maneuvers. You won't get far with this rocket, but it should get you into orbit. We also have the lower part, which is going to be fired after the solid engines. I don't know why I'm doing this with my hands, because you can't see it. But after the solid engines are fired and been expended, they'll be detached. Then the liquid engine will take over as the main source. And that is used for establishing the orbit and just getting up into space and getting into a stable orbit. Now, before we launch this thing, I want to go over a few points. We have the centre of mass. The centre of mass is unbelievably important. If the centre of mass is not in the middle, then the way gravity will work on it is not... well, it's going to make it very unstable. I mean, let me give you an example. If I... let's grab this and put one of these and just throw one of these on the side here. Now what that's done is it's moved the centre of mass to the side. So when this thing is going up, gravity is not going to be affecting it on the middle. It's going to be affecting it on the side, and that's going to cause it to dip. Like, there's too much mass on one side, so it's going to dip to the side. Plus, centre of thrust. Centre of thrust is also not in the centre. That means it's going to be pushing too much to one side. So the thrust is going to basically push the craft over. Best way to describe that is... Let me think of a good way to describe it. if you're pushing an object and you're using both hands on the object, pushing equally on the object, it will go straight. If you start pushing harder with your right hand, the thing is going to turn, and then it won't keep going in the same direction. It's the same with the centre of thrust. If the centre of thrust is not in the middle, behind the mass, then you're going to have to adjust how you're pushing the thing to keep it going straight. Aerodynamics we don't need to worry about at this point. That's for space planes. Right, okay, so let's go with test flight 1. So, pretty basic. We've got Jeb at the wheel. Right, sorry about that. My flaps stopped for some reason. Thankfully, I noticed it just at the moment it stopped. Okay, so we have our test flight set. So what we're going to do is we are going to move to the rocket launch pad. Okay. So here we have our little Jeb down here. We have our order, which you can adjust on the launch pad. So solid fuel will fire first, then detach, then the main liquid engine will fire, and then once that's done, that will detach. We have the smaller liquid engine for all the other manoeuvres. When we're on re-entry, we can detach that and fire up the parachutes. I'm trying to remember what that was then. Okay, so first things first, SAS. You press T to turn it on. That is unbelievably important because the computer will do its best to stabilise the craft as it's going up. And I use this all the time. If you've got a pilot on, you can turn on the SAS. Many unmanned craft also have SAS on them, but there's a specific part for that, and I'll go through some of those parts once we've actually engaged this. So, press space, and oh wait, no. Get the thrust up, press space, and we fire. So now we're going up. Now, first things first, what I tend to do is I manoeuvre my craft slightly to the right while we're going up. Now, as you can see, we're generating this nice little drag effect. That means that we are doing our best to cut through the atmosphere. Now, in the lower part of the atmosphere, you're being slowed down more by wind resistance, quite a lot. So, this is why I use the solid fuel engines for this point. And I try and get up to 20,000. Okay, there we go. Now, I could detach at this point, but I found every time I try to at this point, the whole thing starts to become unstable. So, I let it coast a little bit. Let me pull up the map. So, at the moment, we are looking to reach that altitude with this craft. Right, we've already reached... Hang on. A lot of things are happening at once. So, the solid fuel engines will take us to a maximum altitude at the moment of 95,000 meters. To achieve a stable orbit, you need to have a circular orbit of a minimum of 70,000 meters. So we're already well on our way to doing this. You'll also notice down here it says orbit now. So we have now left. We're now very much in the upper atmosphere, and it's now considering that we are now in an orbital manoeuvres position. It's something to do with the way the game judges it, so you can change that just by clicking on it, but we won't go into all of that quite just yet. Now, obviously, the solid fuel engines have run out of juice. We are up in a high position, so space to detach those, space again to fire the next part. Now, because we're not in the atmosphere anymore, and I'm just going to pause it again. Because we're not in the atmosphere anymore, the wings are useless. So, we're not being turned by the wings anymore. In fact, the only thing that is really turning us is the gimbaled engine on the liquid engine and the reaction wheels that are inside the command module. Not all not all unmanned craft and command modules have reaction wheels on them. There are specific parts for that, and I'll describe how that all works in a little bit. But for now, what I've done is I've adjusted my position so that I'm sideways on, and the reason for that will be described from the map. Because now we need to circularize this orbit. Now what I'm going to do is just adjust my trajectory down a little bit, because what we want to do is to stop gaining altitude and sort of get a nice equilibrium. And the way this works, so for pausing again, you'll see down here on the little globe we have if you add more to a rocket, add more mass to it, you need you either need to add more thrust to it, or more fuel to it. But of course, adding more fuel to it adds more mass. Thank you Windows, for telling me my computer's running out of space. Actually, I think for that reason, I'll have to cut this episode here. But once we come back, I will explain more about some of the core mechanics. Things like delta V, mass to weight ratio, well, we'll go over the various parts. But basically, this is getting into orbit, and I'll explain some of the more core components to it as we go. In the next episode, we'll also do a controlled re-entry to show how to get this thing back. But let's go to the Space Center. But anyway, this is the first, or I hope the first video. I haven't broken it down to several ones, depending on the size, but this is the first video of this little series. I hope this has proven useful to you. Let me know in the comments if you have any questions about anything that goes on in this, or if there's anything you want me to go over. But thank you guys so much for watching. There'll be more information in the next video. I'm Blackendrose, this is Kerbal Training Academy, and I will see you in the next video.